So boxplots are a good way to learn about the distribution of your data, although strictly speaking, they are not showing you the whole distribution as we did with density plots, for instance. This is a way to compactly display the summary statistics, so not the whole distribution, of one continuous variable. The anatomy of a boxplot is the one that you can see here. So in a classical boxplot representation, we will have information about the median, which is represented by this segment here. Then we will have two hinges, which are these two rectangles, which contain most of your data points. And then we have two whiskers both at the left and at the right. And that means that there is less data there. And then finally, you have all the outliers or the outlying data points of your data set at both extremes of the whiskers. To draw a boxplot in ggplot, we are going to use the geometry geom boxplot, which by default uses the statistical transformation stat boxplot. So let me just illustrate you what it looks like. So let me use the MPG dataset, and for the aesthetics, I want to see for each one of the classes of the cars, the highway consumption summarized in a geom boxplot. So this is what we obtain if we execute this sentence. As you can see here, this is the anatomy we precisely were talking about. And also, as you can see, there are some cases in which we don't have the two whiskers because there's not data here. Or also in some cases, we don't have outliers both on top and on the bottom. It just depends on your data. So if you take a look at the help page for the geom boxplot, you will see that there are many parameters that you can tune to make your boxplot suited to your needs. And I want to comment some parameters that I find interesting. So the first one is very easy, it's just the width parameter, which basically will tune what is the width of all of the boxplots that we have drawn here. Because sometimes these are very wide and you might want to increase the space between them. So a way to quickly solve this is to specify a smaller width. So for example, this would be exactly the same representation, but where boxplots are more narrow. In relation to this, there's another parameter called bar width, but this parameter doesn't accept a number. It is only a Boolean parameter. So either you set bar width to false, which is the default, or you set it to true. And what it does, it's very interesting because one of the problems that we usually have with boxplots is that they hide the sample size. So at the end here, you have the summary statistics of each one of the classes of the cars, but you don't know how many observations or how many cars we have in each category. So a nice way to approach this would be to set the var width parameter to true. And that means that the width of each one of the boxplots will be proportional to the number of points that we have in each one of the categories. Okay, so as you can see, in the two-seater, we have a very small sample, but for compact and mid-size, we have some bigger sample. Actually, another way to reinforce this information about the sample size would be, for example, to use a geom point with some jitter on top of the boxplot. Probably you would have to add some alpha to make it more transparent. And so now you can see that, for instance, in this category, the two-seater one, we only have 5 data points. And for the compact category, we have many more data points. That's why this is wider and this is narrower. Another possibility to display the sample size would be just to put a label with the sample size on top of each one of these categories. Another thing that we can do to help boxplots be more intuitive is to use different colors for the different categories that we are representing. So if you let me go back to our first example, which was this one, the way to add a color would be to specify that fields should follow class in the aesthetics of boxplot. But now what we obtain here is a plot that has a legend here. And this is repeated information. Actually, this legend, I don't need that one because I already have the class here. So in Boxplot, there is another parameter which I use a lot, which is show legend, which basically sets to true or false if you want to display this legend here on the right. So let me just state show legend false. And now I have removed the legend. Okay. Now let's say that I like these colors, but I want to add some alpha to these colors. The normal thing to do would be just to come here and state that alpha should be, for example, 0.2. Okay, and let's say that I like these colors like they are. But now I have a problem. As you can see, the outliers have been affected by the alpha as well, so that now I don't see them very well, and I only wanted the alpha to affect the filling. Okay, so there's a set of parameters that control the appearance of the outliers. So we can use this outlier alpha parameter to set it to 1 so that the alpha that I just mentioned here only affects this part of the plot. So if I say outlier alpha equals 1, that means no alpha, no transparency, I get all my outliers back. And now that we're mentioning the special characteristics of outliers, there is another thing that you can change with Boxplot, which is outlier shape. So this parameter here accepts a code number for each one of the shapes, which in ggplot are these ones that you can see here. Actually, these are the official codes for all of the symbols that you can use in scatter plots or any time that you are using something with geom_point. And you can change with this the shape of the outliers. So for example, let's say that I want my outliers to look like crosses, like number 4. I could do so by saying outlier shape equal 4. And so now I have these crosses here. Or maybe I was happy with the default, which was 19, this big dot here, but I want it smaller. So let me turn it to 20. Okay, so that's a box plot that I like better. Actually, the most common way to represent a box plot is using dots as the outliers. So I wouldn't recommend you getting very creative with changing this shape because in the end, you want people to recognize that these are the outliers. So probably don't change it that much. By the way, we can also use outlier shape to get rid of these points. If I set outlier shape to non-available, it will remove the outliers from my plot. But although you can see them, they are there, it's just that they are invisible. That means that when ggplot calculates how big this region has to be, it takes into account these points. So the scales will be calculated with the points, okay? So in the next lesson, we will learn how to make box plots look better.